Hello everyone, welcome to Learner's Repository. In today's session, we learn about doubly linked list. To know about various topics under data structures, kindly visit my data structure playlist. If you have not subscribed to my channel so far, kindly subscribe and support me. Before knowing what exactly is doubly linked list, we should know why are we going for the concept called doubly linked list. There are some drawbacks left with singly linked list. We'll see the drawbacks one by one. On a singly linked list, wherever there is free space in memory, your nodes will be scattered and all the nodes will be connected through pointer variables. So we'll be able to traverse only in one direction, that is forward direction. The reverse traversal is not possible in singly linked list, which is the first drawback. The second drawback of singly linked list is during the deletion operation, we are supposed to have an extra pointer variable to keep track of the previous node's address. This pointer variable occupies an extra space, which is a drawback of singly linked list. To overcome all the drawbacks of singly linked list, we are moving on to the concept called doubly linked list. As the name suggests, it is a bidirectional linked list, and each node of a doubly linked list will be represented as follows. Every node will be having three parts: the data, previous, and the next. Previous and next are the pointer variables. Previous keeps track of the previous node's address, and next is a pointer variable that will be keeping track of next node's address. Let us now explore the logical representation of a doubly linked list. As we know, head is a pointer variable that will be holding the address of my first node. My first node is 100 here, so it is a pointer variable. It will be pointing to 100. Since there are no nodes before the first node, the previous part of the first node will be null. Similarly, the next part of the last node will be null, because there are no nodes after the last node. So the next pointer of my first node will be pointing to the address 200, establishing a connection in forward direction. Similarly, my previous part of the second node will be holding the address 100, establishing a connection in backward direction. As you can see, linked list, that is doubly linked list, are bidirectional. So the next pointer of my second node will be pointing to the address 300. And the last node's previous pointer will be pointing to the address 200. So this is how we logically represent a node in a doubly linked list. Let us now learn how to write the structure definition of a node of a doubly linked list. So struct followed by a structure name, it is node here. Each node will be having three parts. The first part is the data part. I assume the set of data as integer values, so int space data. Next and previous are pointer variables, which will be in turn pointing to a node again. So it should be represented as a self-referential structure. Always a structure definition should be terminated. So this is how we write structure definition for a doubly linked list. Stay tuned for all the other operations of a doubly linked list. I'll see you on my next video.